On number 44, we are to describe how to transform the graph of the natural log function into the graph of the given function. Then sketch after we've described the transformations. Well, we see two transformations here, and one is the negative on the inside, and the other is the minus 2 outside. Well, the minus 2 is simply going to do what it's done the whole time, all the way back to parabolas, when you studied those. It's going to take the parent graph down 2, and the negative x on the inside is going to reflect the parent across, or in is the technical term, but across the y-axis. Because remember, anything that's done inside is backwards and has a horizontal effect on the graph. So the first thing I would recommend is that because these graphs are so new to you, that you actually graph the parent, at least until you get comfortable with the logarithmic structure. And remember, the logarithmic graphs are simply inverses of the exponential graphs, and since all exponential graphs go through the point 0, 1, all of these graphs will go through the point 1, 0. And then the next point depends on what the base is, because we're going to look at the point one step to the right on the e to the x graph, which would be the point 1e, which means here we're going to go to the right e and up 1. Well, e is just approximately 2.7, so I'm going to take approximately 2.7 steps to the right and up 1 and plot the second point. The next thing to take into account is the fact that all logarithmic graphs come down. Let me see if I can do a little better job than that. Come down and hug the vertical asymptote, which is the y-axis, in the same way that the exponential graphs go back and hug the x-axis towards negative infinity. And then once you draw that part, come back to this point. Let me see if we can do a little better there. You want to make it a smooth curve that flows right out that way. And remember, it should be a reflection of an exponential, so it should look like an exponential turned vertically instead of horizontally. So that's the parent. So now let's switch colors and graph the transformed version of this. Well, let's take care of the reflection first. And I'm just going to put some little marks, and then we'll deal with those to get the final picture. So we'll start with the reflection. So we're going to reflect these 2 points we just drew. So this point, 1, 0, is now going to become negative 1, 0. So I'll put a little x there. This point, now we're going to go to the left 2.7 and up 1, which will put us about there. So you can see that this graph would look roughly, and I'm going to kind of sketch in where that's going to land. But we don't want to get the full graph there, because now we still have to go down 2. So we're going to take each of these points and move them down 2, and then we'll plot these. So I'm going to plot these 2 points. And then I'm going to erase these other marks on this side just so they won't get confused with my graph. Let me get my eraser a little smaller so I don't mess up the other stuff we've done here. Alright, and then there's my 2 points. And so I'm ready to sketch my picture here. So this tail should come down and hug the vertical asymptote, and then the curve should come up and out with the same kind of shape. This is probably a little too horizontal. Make it go on up, because they do go up forever, just very, very slowly. And the green one is our final graph. Now we'll start with green on this second one, and then switch to blue for the final picture. Again, we have to account for the transformations. Well, this is a different base, but it's still a logarithmic graph. All logarithmic graphs have the same basic features in their shapes, in the same way that all exponential functions have the same basic shapes to their features. So here we have a negative 3 multiplier that we didn't have, and we have stuff going on the inside, which we're going to deal with that in just a second, and then we have a plus 1 outside. So the negative 3 and the plus 1 are pretty straightforward. Let's go ahead and write those down and come back to that inside stuff, because this one's one of the tricky ones. Our negative 3 multiplier on the outside is going to cause a vertical stretch by 3 with a flip. and we'll call it a flip. It's going to turn it upside down, just like the negative a on a parabola turns it upside down. All right, and then we also have this plus 1 outside. And this, again, anytime we add a number outside, it moves the graph up 1. So we've taken care of those, but we have to come back and take a closer look at this inside part. So let's rewrite our function. Remember, anytime there's a minus on the x and you have an added or subtracted number, you should factor the negative out of both. So that would be negative, and then in parentheses x minus 1, because if we distributed that negative back, the x would be negative, and the 1 inside would be positive as it appeared in the original function before I rewrote it. So now this helps us see exactly what's going to happen. So there's really two changes on the inside. The negative x is going to cause us, and we'll write that in parentheses again to remind ourselves that was on the inside, is going to reflect it horizontally, or we could say over the y-axis like we did on the last one. You say over, across, or in. In is the technically correct, but over or across kind of tell you more. All right, and then we want to address the fact that we have the now minus 1, so that moves it to the right 1. And I left off the minus 1 there. Let's just take all that back off. Here we go. Minus 1 is going to move the graph to the right 1. So let's see if we can't get all this on this picture. Again, we'll start with the parent. So let's plot our parent points, and then we'll go to blue to graph the graph of this function they gave us. All right, remember that 1, 0 is on all all logarithmic graphs in the same way that 0, 1 is on all exponentials. And our base here, because this is log without a number, is log base 10, which means we would have to go 6 steps beyond our picture to get to 10. So that'd be, and I'm actually going to draw it. In fact, I'm going to switch colors so you can see it in the midst of all this to red. If I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I would be roughly right here when I go up 1. Let me see. You can't see that because my pen's not cooperating. There we go. There's that point way out there. All right, and then we're going to come down and hug the vertical asymptote, and then it's going to go very, very quickly flat, looking out that way. Because 110 would be on 10 to the x, so 10, 1 would be on this graph. All right, now let's switch back to our blue to get a picture of the function we are to draw. Well, this one's going to have a lot more going on than the last one, so we're going to do a little bit of scribbling and then take it back off. All right, so we're going to deal with first this closest point. We're going to reflect it across the y-axis first. That's just my preference. I think it makes it easier. If I move that one over first, or not move it over, but reflect it first, and then I'm going to reflect the second one. Barely gave myself room for that, would be right there. But that's not where the graph is because we have other things going on. The first thing we want to deal with in getting our final picture is to move these points up 1. So we're going to go up 1 for each of those, and then we're going to come back and erase the ones we just drew. So we've taken care so far of the negative x and the plus 1 outside. We also had a minus 1 inside, which means that these points are actually going to go to the right 1. And notice I'm still not putting actual points, I'm putting x's because we haven't dealt with the negative 3 stretch and flip that we're going to get from that. So I'm going to come back and take off that second round of sketched points. And then now we're going to deal with the negative 3 multiplier on the outside. We're going to do it kind of all in one. So remember, a negative outside turns the graph upside down. So it's going to swing from this pivot point, which is now at 0, 1. So whatever would have been on the x-axis is where is the place from which it flips. So we've really got kind of an x-axis across here where that point is. So that point is actually going to stay. All right? And then instead of going up and over to the X that we had marked last, now we know we're going to go to the opposite side and make our point. And then our vertical asymptote has moved to the right one after the reflection. So it's going to come up like that and then swing out and hit that point way out there. I kind of hit it. That's close enough. And that's what number 52 looks like.